Hi everyone, my name is Griffin Higgins, and today we're going to be talking about establishing secure connections between two untrusted hosts over an insecure network. For this, it's going to be good if you have a little bit of a background with shell commands, and also some networking background is going to be good too, but if not, no worry. So the thing we're going to be talking about the most is SSH protocols, and one of the tools that implements it called OpenSSH. I hope you kind of learned some cool tricks about this, and we're going to talk about some really neat things like identity files at the end. So let's start with a high-level overview. Imagine we have two machines, which I'm going to draw with squares because I'm not good at drawing computers. And they need to communicate with each other. And let's call this user alpha and user beta. One of the main problems is that if this occurs in the clear, and let's say that we're sending soft like passwords, if there's anyone eavesdropping on the conversation, we have like Oscar or someone, then those credentials could be used to log in to beta. So one of the main problems is ensuring that in between here and here, that this communication is encrypted. And that's where SSH comes in. So how does SSH work? SSH uses a client-server architecture that usually happens over a TCP connection. In order for this to occur, alpha needs an SSH client, which will denote _C, and beta needs an SSH server, which will denote _SSH server. If neither of these are working, then there won't be an SSH connection and it will be refused. If these are working, then alpha also needs to know some information about beta. Obviously, they need to know the username, but they also need to know login credentials and the host name. For example, the Raspberry Pis, which I'm going to be demonstrating later, on my local network, one of them is 192.168.2.20. And I also know the password. So to specify this in SSH in a moment, what we're going to do is we're going to open up that secure TCP connection. And we're going to specify that we want beta at 192.168.2.20. And then once we provide the password, then we'll have a root, or not a root, login shell, a login shell, and the connection will also be secure from people like Oscar, so that if they try to log in with any credentials, they won't actually be able to see them because they'll be encrypted.
So we managed to survive my box drawings, and now let's jump into a quick demo with SSH. So in order to use SSH, we're going to have to assume that there's a client on our local machine for SSH and that there's a server on our host machine that's listening for SSH connections. The first thing we're going to do is type SSH, the user we want to connect to, at the machine we want to connect to. So the host name, so 192.168.2.20. So when we try and log in for the first time, it's going to ask us if we really want to connect to it, and it's also going to give us a fingerprint, and we're going to say yes. It's also going to say that it's permanently added that host name to the list of known hosts, and it's also going to prompt us for a password. And we're going to give it a password, and we're in. So now we're on our remote machine, and we can start executing commands just as if we were on our local machine. So we can type ls, for example, and it will give us the listing of our home directory. But this is cool and all, but supplying passwords is tricky because sometimes you'll forget them, or if there's no limit on the number of passwords you can supply, then someone could potentially brute force the list with common known passwords. So now we're going to talk about a different tool that will actually bypass this for us. So going back to our previous reset example, instead of supplying passwords, we can actually use something called identity files. To start this off, we're going to use something called SSH keygen, and it's going to generate a public-private RSA key pair for us. And we can also specify where we want it to save, but this is fine for me for right now. You can also give it a passphrase, but I don't need one. And it's also going to give us a little piece of random art and a fingerprint, which I think is cool. You can visually compare keys. But now that we have that, we can go take a look at it. So we can go .ssh. I'm going to use a command line tool called Ranger, and we can look at our keys that we just made. So this is our private key, ton of gibberish, and here's our public key. So what we're going to do is we're going to copy our public key. So we're going to say cat id rsa pub to our clipboard. It might be something else on Linux or Windows, but this is how to copy for clipboards for Mac. So once we have that, we can SSH into our remote host. So we can say SSH pi at there. And we're going to say yes again because this is the reset example. And we can say that we trust it. We're also going to give it the password for the first time. And then we're going to be logged in. Now that we're here, we need to make the SSH directory. And then we can cd.sh. And we also need to add that public key to a list of authorized keys within our SSH folder. So all we're going to do is we're going to paste in that public key, and we can actually see that there's other information about our local machine so that it knows where we're trying to log in from and some other information. So once we have that, we're going to save and exit. And then once we go back to our local machine and we try and log in again, we can actually specify an identity file. So we can say I at our home directory .sh.id RSA, and this needs to be your private key. And now when you try and log in, you'll be dropped right in and you don't even have to supply your password. So now instead of setting up a key by copying and pasting it over, let's speed run an example with a new machine. The first thing we're going to do is generate a new key pair, and I'm going to give it a new location at jd_RSA. So we're going to accept that. And now what we're going to do is we're going to use a new command called SSH copy ID. You need to give it that key and also specify where it is. This is a new machine. It's at .19 instead of .20. So we're going to copy it over. Yes, we want to accept, and we want to give it a password. Once that's there, the keys will be added, and we'll actually be able to log into the new machine. And it's just that simple. Thank you for listening to my presentation. If you have any questions about disabling password login or SSH configuration, please feel free to reach out. Thank you.